Let's talk about Liquid 1074, number of submetrics that sum to target. So for this question, it gives us a matrix, and let's find the submatrix which has sum equal to target. We want to know the numbers. So for example 2, the target is 0. So the result, there are 4 submetrics equals to 0. So intuitively, what we're thinking about is that we can use create a prefix sum for this matrix and iterate the upper left um, cell and also the bottom right cell, but that will be all m square n square time complexity, right? But we can do things better. That is, for every column, we create a prefix sum for the columns, right? So that is called a column prefix sum. And then we iterate those kind of star row and end row, right? So we have a compressed cell every time we iterate this star row and row, right? So that for the compressed cell, right, it is an integer array which have the length with the same as the length with the column, right? So for this one, what we need is just find how many subarrays in this compressed array has sum equals to the target and add to the total result. Um, so this one we can look at thinking as a separate question, right? For array, how many subarrays equals to target? We could use a map and put the prefix sum, right? Initially put the 0 and a pair to 1 times. And every time we update the prefix sum and find the prefix sum minus target, how many times it appears, right? And add it to the result and then update, put the new counts of the current prefix sum should plus equal to 1 update to this kind of value, right? So let's write code for this. We need a column prefix sum. Um, what we do is that we are call column prefix sum equals new. So we are, because that is for each column we'll have prefix sum. Prefix sum, we're going to have one more index, right? But column, that is same as the index, right? So what we do is that for int column equals 0, column equals n, column plus plus. So for how can we calculate the prefix sum int I equals 1, I smaller than m plus 1, I plus plus, right? So why we use I? Because this prefix sum index, right? It is one more than the row index. So will be column prefix sum I column equals column prefix sum I minus 1 column plus matrix I minus 1 column. So we have a column prefix sum. Then let's have a result. So we need to initialize, iterate the start row and end row, right? For start row equals to 0, start row equals smaller than m, start row plus plus. For int end row equals start row, end row smaller than m, end row plus plus, right? So we have a compressed array equals new int n. And then what we do is that we just for int colon equals to 0, colon smaller than n, colon plus plus compressed array colon equals colon compressed colon prefix sum on n row plus 1, right? Colon minus colon prefix sum. Arrow colon. And we have then we are just look how many subarrays in this compressed array, which sum equal to target. So what we do is that int column prefix sum equals to 0, right? So we need to have a hash map, which the key will be the prefix sum. The value will be the counts for this prefix sum. So we know initially we should put a 0, 0, 0 as add a 0 prefix sign 0 as one more, right? We add one more index, it appears one times. So we should put a value 0, 1, right? Current prefix sign. It appears once, right? So then what we do is that for every interval in compressed array, we try to have a current prefix sum should plus equal to v, right? So our result should add equal to map get all default current prefix sum minus target 0, right? And also we need a map merge current prefix sum 1 integer sum. In the end, we just return result. Okay, so doing like this, we time complexity originally we use the brute force that will be n square m square, right? But here we have only two for loops, so that will be m square, and we this is O n operation, right? After we get we'll have O n operation to get its compressed array, right? And also we use a map, right? So this is also O n. So the time complexity will be O m square n, right? For space, right? Space, of course, you can reuse the matrix if you don't have extra space, but it change the original input. So we use a compressed prefix array. So the space complexity will be m multiplied by n, right? So someone is asking, we have two for loops and have compressed um, and a map in a for loop. So whether we, for example, the compressed array put outside and then the map put outside will save the space. It is actually not. If we put outside, we should have extra step to clear map and clear this compressed array, right? The things that the this kind of local variable, the the lifetime is that when they going out of this for loop, those kind of variable is going to end its life. So actually, for this map, and every time we renew new map or new compressed array, right? It is the same effect as we put this outside. So this is the O n, right? If you don't believe that, you can also extract this into a method, right? Because the method it that is it will extract after method call, so it's the same as O n, right? So the time complexity will be O m square n, and space is m multiplied by n, and the Python code is very similar. Let's have uh, m n equals length matrix and length matrix 0. And we have a column prefix sum equals, so we will have the same column number with the original. And for this one in range m plus 1, right? The row should have one more. So what do we do is that for column in range n, and let's say for I in range from 1 to m plus 1, right? Because this index, we don't use row because it's one more than row. So I have column prefix sum I column equals column prefix sum I minus 1 column plus matrix I minus 1 column. Okay, so we have column prefix sum. Then what we do is that we have result equals to 0, and for start row in range m, for n row in range from start row to m, right? And we'll have compressed array equals this one multiplied by n. Then we are going to get this compressed array, right? For column in range, and so we're going to have compressed array column equals column prefix sum and the row plus 1 column minus column prefix sum star row column. Right? Then we just look for this kind of compressed array, how many subarrays which sum up to target, right? So we'll have current prefix sum equals to 0. So we're going to have map prefix map equals default date int. Okay. So p map we are going to have 0 equals to 1, right? And for v in compressed array, we're going to have c prefix sum plus equal to v, and we'll have result should plus equal to p map c prefix sum minus target, right? And also we should have p map current prefix sum should increase the counts, right? Plus equal to 1. And return result. Column prefix. Mhm.